Students of class 10, in my last video, I worked out up to question number 8 of exercise 8.1, Introduction to Trigonometry. Now I am coming to question number 9. The question number 9 is given in triangle ABC, right angle at B, tan A is equal to, if tan A is equal to 1 by root 3, then find the value of sin A cos C plus cos A sin C. How will you find it out? Triangle ABC, right angle at B, so B is 90 degree. You are given tan A is equal to 1 by root 3. From the given condition, you are to proceed. Given tan A is equal to 1 by root 3. Now what is tan A here? Acute angle A, so AB is base and BC is perpendicular. Tan is base to perpendicular, so BC by AB. So BC by AB is root 3. BC by AB is equal to root 3. Therefore, AB is equal to cross multiplication. AB into 1 is AB. AB is equal to root 3 BC. Root 3 BC. From this relation, we can find out what is AC. Therefore, AC is equal to root over AB square plus BC square. Pythagoras theorem. Perpendicular hypotenuse square is equal to perpendicular square plus base square. So hypotenuse is square root of perpendicular square plus base square. Ultimately, what is AB? AB is root 3 BC. We can write root 3 BC whole square for AB square, and it is BC square. So ultimately what we get? We get AC is equal to, is equal to root over root 3 square is 3 BC square plus BC square is equal to root 4 BC square is equal to square root will be 2 BC. The square root is 2 BC. Ultimately, what we have found out? We have found out AC is equal to twice BC. So from this relation, we can find out whatever is given in your question. Sin A, therefore, sin A cos C plus cos A sin C is equal to, what is sin A? Sin A is BC by AB. Sorry, sin A is BC by AC, not AB. Perpendicular by hypotenuse. What is cos C? This acute angle C, so this is base. Cos is base by hypotenuse, so BC by AC. Plus cos A. Again, for acute angle A, with respect to A, this is the base. So AB by AC. Base is to hypotenuse. AB by AC. and sine C, for with respect to this angle, this acute angle C, perpendicular is to hypotenuse is sine, so AB by AC. So what we get? BC into BC by AC into AC. BC square by AC square plus AB square by AC square. AC square, and ultimately the numerator will be BC square plus AC square. BC square plus AB square. Again from Pythagoras theorem, AB square plus BC square is AC square. So AC square by AC square is equal to 1. So ultimately, in this problem, this given condition is not at all required. We have not applied this given relation at all. Although we found out AC is equal to 2BC. So if we write, we can write AC is equal to 2BC. 2BC whole square by 2BC whole square. Then also it means 1. So actually this was not at all required. Similarly, now cos A cos C minus sin A sin C. The next one, Roman 2. Cos A cos C minus sin A sin C. Later on you will find this is also one formula. Cos A cos C minus sin A sin C. Now cos A is base by hypotenuse, so AB by AC. AB by AC. Cos C, BC by AC. Minus sin A. Sin A is BC by AC. Perpendicular by base. Sin C, AB by AC. AC into AC, AC square, it is AB into BC. AB into BC. Minus, here also the denominator is AC square, BC into AB is AB into BC. Both are equal, so if subtracted, the result is 0. So we have not applied this given relation at all. It becomes 0. Okay. Now let us come to question number 10. Question number 10 is, in triangle PQR, right angled at Q. Triangle PQR, right angled at Q. PQ is 5 centimeter. Let this one be PQ. This is given 5 centimeter. And also PR plus QR, sum of these two is 25. PR plus QR is equal to 25 centimeter. PQ is 5 centimeter. Determine the values of sin P, cos P and tan P. So from this relation, actually you need to find what is PQ, what is QR and what is PR. How can we find it out? We have PQ square plus QR square is equal to PR square from Pythagoras theorem. Perpendicular square plus base square is equal to hypotenuse square. Implies PR square minus QR square is equal to PQ square. You see, PR square minus QR square is equal to PQ square. Now apply the factor formula. A square minus B square is A plus B into A minus B. So PR plus QR into PR minus QR is equal to PQ square. Implies PR plus QR is given 25. PR minus QR, 25 into PR minus QR is equal to PQ square. What is PQ? PQ is 5. 5 square. So what we get? PR minus QR is equal to 5 square is 25. 25 by 25 is 1. Now, PR plus QR is equal to 25. Take it as equation number 1. And PR minus QR is equal to 1. Take it as equation number 2. From these two equations, we can find what is PR and what is QR. Solution of linear simultaneous equations. So if we add these two, we get twice PR. This one 0 plus QR minus QR 0, 25 plus 1 is 26. So PR is 26 by 2 is 13. Now if we put 13 for PR in any of the equations, putting PR is equal to 13 in equation number 1, say. So PR, for PR we write 13 plus QR is equal to 25. It means QR is equal to 25 minus 13 is 12. Thus we have found out QR is 12 and PR is 13. This is 12 and this is 13 centimeter. Now we can find it out easily, whatever is given. So first one is sine P. Sine P. This acute angle, with respect to this acute angle P, it is base, it is perpendicular and it is hypotenuse. Sine is perpendicular is to hypotenuse. So QR is to PR. QR is to PR. Already we have found out QR is 12 and PR is 13. So sine P is 12 by 13. Then cos P. Cos P. Base is to hypotenuse, so PQ is to PR. PQ is to PR. PQ is given 5 and PR already found out 13. It is centimeter, it is also centimeter, centimeter, centimeter cancelled. So in trigonometric ratio there cannot be any unit. And the next one is 10P. 10P is equal to, you know, 10 is perpendicular is to base. With respect to angle P, QR is perpendicular and base is PQ. QR we have found out 12 and PQ is given 5. Thus we have found out sine P 12 by 13, cos P 5 by 13, 10P 12 by 5. So question number 9 has been completed. Question number 10 has been completed. Now come to question number 11. Question number 11 is, state whether the following are true or false. Justify your answer. The value of 10A is always less than 1. They are saying 10A always less than 1. Is it true or false? You know, 10 is the ratio of perpendicular and hypotenuse. In a right angle triangle, the hypotenuse is always greater than the other two sides. So if the denominator is greater than the numerator, it is always less than 1. So it is true. Is true. Is true. As because tangent of an angle is the ratio between perpendicular and hypotenuse. Perpendicular and hypotenuse. is always greater than the perpendicular. So with a greater denominator, the fraction is always less than 1. For this reason, the first statement is true. Now come to the second one. They have given sec A is equal to 12 by 5. Sec A is equal to 12 by 5 for some angle, some value of angle A, for some A, for some A, whether it is true or false. We know sec is the ratio of base is to hypotenuse. Hypotenuse is to base, sorry. Sec is the ratio of hypotenuse is to base. Here the numerator is greater than the denominator. So it is true. The given statement is true. Is true as because secant of an angle is the ratio hypotenuse ratio of hypotenuse is to base, and the hypotenuse is always greater than the base. So sec A is equal to 12 by 5 is true for some angle A, as because secant of an angle is the ratio between hypotenuse and base, and hypotenuse is always greater than base. Here the numerator is greater than the denominator, so hypotenuse is greater than base. Okay. Then the next one is cos A is the abbreviation used for the cosecant of angle A. Cos A is for cosecant of angle A. It is not true, as because cos A means cosine of A, not cosecant of A. is not true, because cos A is cosine of A. So cos A means it is the abbreviation of the cosine of angle A, not cosecant of angle A. Cosecant of angle A is cosec A, not cos A. Then the next problem is cot A is the product of cot and A. Cot A is the product of cot and A. It is not true. Is not true. Because cot A is the abbreviation for cotangent of angle A. Cot A means cotangent of angle A. It is not like algebra xy is equal to x into y. It is cotangent of angle A, cot A. And the last one is, the last one says sin theta is equal to 4 by 3. Sin theta is equal to 4 by 3 for some theta. For some angle theta, that is, whether it is true or false. We know sine of an angle is the ratio of perpendicular and hypotenuse. Here it is 4 by 3. Numerator is greater, denominator is smaller. But perpendicular by hypotenuse, so denominator should be the greater. Here the denominator is smaller. So it is not true. Is not true. As because sine of an angle is equal to perpendicular by hypotenuse. And the hypotenuse is always greater than the perpendicular. Always greater than the perpendicular. But here we see the denominator is smaller, so it can't be. Okay. So Thus we have completed exercise 8.1. Now we are coming to standard angles. I am going to give you the table for the standard angles of the trigonometric ratios. The standard angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. How to prepare the table I am going to give you now.